So today we will talk about cofactors. But before talking cofactors, you know in enzyme there is one protein part in the enzyme itself, the protein part, right? Plus there is a non-protein part, right? And when a protein part of the enzyme combines with non-protein, it is known as holoenzyme. It is known as coenzyme. It is known as holoenzyme. So basically, the protein part itself is known as the protein part is known as apoenzyme. That is known as apoenzyme, and the non-proteinase part is known as cofactor. The non-proteinase part is known as cofactor, and the enzyme formed is known as this holoenzyme, or you can say it is a conjugated enzyme. It is conjugated enzyme. This is conjugated enzyme, right? Now, okay, so now let us clarify this cofactor. So this cofactor can be organic and can be inorganic. Basically, it is divided into three groups. This cofactor is divided into three groups. Okay. Number first is we are having is our activators. Our activators. Basically, these activators are nothing but they are, wait a minute, these activators are metallic ions. These are metallic ions, or you can say these are salts basically. These include, for example, magnesium plus 2. For example, we are having calcium plus 2. So these are the basically the metallic ions which are used as activators as a cofactors. Okay, these actually activators are detachable. They can be detachable, right? Now let us discuss about now let us discuss about the prosthetic group. Prosthetic group. For example, in prosthetic group, we have the example of basically they are organic. They are organic and they are tightly bound, or you can say they are covalently bound to the enzyme. They are covalently bound to the enzyme, right? Okay. Now the second is where should I write? Okay, here. Okay, I should write over here. So second is coenzyme. Basically, these coenzymes are inorganic molecules. These are inorganic molecules which are loosely attached. These are basically loosely attached. They are loosely attached to the enzyme. These examples include what is happening. Okay, let me cut this one. Right, this is a part of activators. Okay, these are basically loosely attached. Right, these examples, okay, you have understood now. These examples include NAD, which is a vitamin 2 nicotinamide dinucleotide peptide is the example of coenzyme, and another example we have, which is NADP. This is also example of this coenzyme. If we talk about the prosthetic group, we have the example of FAD. FAD is the example of prosthetic. So I hope this cofactor is clear to you. This non-protein part is known as cofactor, and protease part plus non-protease part is known as holozyme. For example, okay, there are some enzymes of the stomach. For example, I'm unable to write. Let me write here. We have enzyme known as pepsinogen, which is the protein part basically. This enzyme known as pepsinogen as is the protein part, right? And it is created by only HCl. HCl is inorganic, so it means it is co. It's not working. It is. Why now this is not working? What is happening, bro? Please wait for a while. I don't know what's happening. This is basically coenzyme. Okay, let me tell you. This is actually the pepsinogen, and pepsinogen is basically the proteinous part, and it combines with HCl, which is a non-proteinous part, and which is actually a coenzyme. So when this HCl combines with pepsinogen, it forms pepsin, which is basically a. So now basically when the pepsinogen combines with HCl, it forms pepsin, so which is a holoenzyme. So I hope this concept is clear to you. Where it is. Okay, I hope this is all things are clear to you.